route reflectors. So in previous class, like in very first class, I discussed I discussed some basics of route reflectors, right? Like in why do we require to have these route reflectors, where we are having IBGP peering and we do not have fully meshed IBGP peering, right? So over there you will always require to configure route reflectors, right? So when you designed to configure your route reflectors, you must remember that over there you will be having three different components. One is route reflector, and then client and non-client, right? Three components will be there. RR is also known as server, right? You can call this RR as a server. RR is route reflector, right? So basically you use this route reflector to break IBGP rule, right? That rule is called IBGP rule. And the rule was like, if you receive anything from your one of the IBGP neighbor, then you will never advertise that information towards any other IBGP neighbor. That is the default behavior of BGP. So to break that default behavior of that BGP, we are having here this route reflector concept, right? Because like for an example, you are having this kind of a scenario. This is your customer edge router that is connected with an ISP, and then further this customer edge router is connected with the router 1, then router 2, then router 3, you understand? And this customer edge router, I mean here this is customer network, and they are using like AS65500 for an example, and this is your ISP. ISP will be using its own AS, so here it will be BGP peering, and then here you can see in between R1 and customer edge router and this R3 and customer edge router, you will be having IBGP peering, right? So here it is IBGP, here again it is IBGP, and this is again IBGP in between customer edge and router 3. Now the point is, if we want that the lane users of R1 should be able to communicate with the lane users of R2 as well as R3, right? So of course R1 must have the lane network of R2 and R3 in its own routing table, and in routing table you will get your routes after having routes in its BGP table, right? Means first it must have all those prefixes in its BGP table. Similarly, R2 must have lane of R1 and lane of R3 in its BGP table, and then after in its routing table. Similarly on R3, but by default, because they all are IBGP peer, right? So of course customer edge, the C router is not going to exchange routes in between R1, R2 and R3. So to solve that problem, you have to configure it as a route reflector, right? So you have to define these all devices as a client. Once you will configure this customer edge router as a route reflector, which means you can also call it server, and of course R1, R2 and R3, they will become as client. Now you will see that R1 will be having all routes of R2 and R3. Similarly, R2 will be having routes coming from R1 and R3, and of course R3 will be having routes coming from R1 and R2. So all of them will exchange their routes information with the help of route reflector. That is why we are calling it as a route reflector, because it will be receiving routes from one of the IBGP neighbor and will be reflecting them towards another, other IBGP peers, right? So that is why we are calling it as a route reflector. I hope that you have understood it till now, right? Fine. But there is a problem. Of course, we have solved this problem with the help of route reflector. I mean, we have broken the rule of IBGP, right? And if you are breaking up the rule of IBGP, right, then there can be routing loop. There can be possibilities of routing loops. Like for an example, this is router 1, this is router 2, this is router 3. Now there is a prefix and .1.0/24, and this prefix is advertised by R1 towards R2 only, not towards R3, right? Let's say this is 12.1.1, this is .2, this is 23.1.2, and this is .3, and this is 13.1.1, and this is 13.1.1.3. Understood? Now R2 is not gonna to forward, by default R2 is not gonna to forward this information towards R3, right, due to IBGP rule. But now you decided to configure this R2 as a route reflector, so you configure this R1 as a client, and of course this R3 as a client for this route reflector, right? So now you will see that R2 will start advertising this prefix that was received from R1 towards R3, right? So now R1 will give this information to R3, right? Now R3 is not gonna to forward it towards R1 because all of them are BGPPMs, right? So R3 is not configured as a route reflector, so by default R3 is not gonna to forward this prefix information towards, back to R1, right? But once you will configure it as a route reflector, you can configure, of course, you can configure R3 as a route reflector. Remember, one client can be itself route reflector. One client can be route reflector itself, right? Means one single router can work as client as well as route reflector, right? I'll let you know, even in most of the cases you will find that, right? Now because you have configured it as a route reflector, so of course you will be defining this R2 as a client and of course R1 as a client, right? Now R3 will also advertise this information back to R1. And if R1 is receiving this route, this prefix coming from R3, it will not make it best, but it will keep it in its BGP table. Once its directly connected prefix will go down, then it will immediately install this route in its routing table via R3. You understand? And there will be a routing loop. So of course there are some possibilities of routing loops if we are using route reflectors, then which means that it is not safer. It's not safe to use route reflectors in our network, right? But we are using all these things on wide scale, and if we are using it on wide scale, which means that there must not be any vulnerability related to routing loops and all. There must not be any formation of routing loop even after using route reflector, right? So of course there are certain rules in BGP even after configuring route reflectors, and which will be really helpful to prevent network from routing loops. And those things will take place after configuring, after implementation route reflectors, right? So there are two things that will be, those will be newly introduced after implementing route reflectors in your network, and those two things are: first, originator ID; second, cluster ID. These two components will take place to prevent your network from routing loops after implementing route reflectors in your BGP. First, originator ID; second, cluster ID. Right? Remember, these two attributes will be attached to your BGP updates while it is giving an update to its IBGP neighbor only. If updates are going towards EBGP neighbor, then you will see that originator ID and cluster ID will be stripped out. Remember, these two things, originator ID and cluster ID, will be included into BGP updates while it is giving an update to its IBGP neighbor only. But if in case BGP is giving an update to its eBGP neighbor, then it will never add these two components in its outgoing BGP updates. Never ever. Same as local preference, if you remember, right? One more thing. Route reflectors cannot be configured for eBGP neighbors because it is not required anymore for eBGP neighbor, because in case if you are receiving anything from one of the eBGP neighbor, you can advertise that information towards all other neighbors, whether it is IBGP neighbor or eBGP neighbor. And of course, if you are giving an update to your eBGP neighbor, then the next hop will get changed automatically. So in case of eBGP neighbors, you are not longer required to configure route reflectors over there, right? That is why if you are giving an update to your eBGP neighbor, these two things will not be included in outgoing updates, because this route reflector feature is just for IBGP neighbors, not for eBGP neighbors. Understood? Fine. How does it work actually? See, cluster ID is always router ID of route reflector. Cluster ID is what? Router ID of route reflector itself. That is called cluster ID. Do not get confused that what is the meaning by cluster ID. So basically cluster ID is what? Router ID of route reflector. Right? and originator ID is the router ID from where route reflector received prefixes. From which, from which router route reflector received prefixes. Let me tell you in this way. Let's say this is router 1, this is router 2, router 3, and this is what? Router 4. And this is what? Router 5. All of them are IBGP neighbors. All of them are participating in common AS, right? So of course they will form IBGP peering now, right? Well, dot 1, dot 1, dot 2, 23, dot 1, dot 2, and this is dot 3, and this is 34, dot 1, dot 3, and this is dot 4, and this is 45, dot 1, dot 1, dot 4, and this is dot 5. And behind R1 we are having a prefix that is called 10.1.1.0/24. Right? Now R1 will give this information to R2. Of course it is that it was self-advertised for R1, right? Self-originated prefix. So of course it will be giving this information to its IBGP neighbor R2. So R2 will install this prefix in its routing in its BGP table actually, and .1.0/24 via 12 dot, tell me, right? Then R2 is not going to forward it towards R3 unless you configure it as a route reflector. Once you will configure this R2 as a route reflector, so let's assume that you have configured it as a route reflector, and let's assume that its router ID is 111. It is, here on R2 it's 2222, on 3 it's 3333, and on R4 it is 4.4.4, and on R5 it is 5555. Understood? Fine. Now you decided to configure R2 as a route reflector. So this R2 has become route reflector, right? And of course you will be configuring R1 as a client, and of course R3 as a client. Now remember, R1 doesn't know that, even R1 doesn't know, or R1 will never come to know that it is working as a client for this, for R2. Never ever. You will simply do configuration only on R2, and you will tell to R2 that okay, R1 is client and R3 is client. And whenever you will configure this R2 that okay, R1 is client, R3 is client, then it will automatically assume itself as a route reflector, as a server. Now R2 was receiving prefixes from R1, right? Now R2 will advertise those prefixes into the direction of, tell me, R3. But remember, after implementing route reflector in BGP, whenever route reflector will reflect any route, see, might be that R2 is having its own self-advertised prefix 20.1.0. It is not reflecting that prefix, right? It is simply advertising that. So whatever I'm going to teach you now is not applicable for those prefixes which are directly connected to route reflector itself, which are self-advertised by route reflector. These rules will be applicable only for those routes which will be reflected by this server, by this route reflector, which means which are received from its IBGP neighbor and advertising them towards other IBGP neighbors. Fine. So there is a rule that whenever route reflector will reflect any route, it will add two attributes onto all those outgoing updates. First, as I told you before, cluster ID and originator ID. So this time, whenever R2 will advertise this tense prefix towards R3, it will add two things. First, cluster ID. In cluster ID, route reflector will mention its own router ID, right? So it will be 2.2.2. In originator ID, route reflector will mention the router ID of that neighbor from where it received that prefix. So from where it received that prefix, from R1. So in originator ID, it will specify 1.1.1. You understand? Fine. Now it will advertise this prefix to R3. Whenever R3 will receive this prefix now, it will compare its cluster ID as well as originator ID. However, this time because we are assuming that now R3 is not working as a route reflector. So if it is not working as a route reflector, remember whenever a route reflector will receive any prefix, it will check its cluster ID first. If it find its own router ID same as cluster ID, it will simply discard all those incoming updates. Which means that, and here you see in this example, right now R3 is not working as route reflector, right? We are assuming that R3 is not working as a route reflector. So this time this R3 is not going to compare its cluster ID because it is not working as a route reflector. Fine. Do you remember AS path list inside BGP updates? Similarly, this cluster list will be added in your BGP updates. In cluster list, it can have multiple cluster IDs because in a single environment, you can have multiple route reflectors. In a single environment, you can have multiple route reflectors. That is why in a single on a single prefix, it can attach multiple cluster IDs inside cluster list. So same as AS path list, it will be having cluster list inside BGP update, right? And in that cluster list, it will be having cluster IDs of all route reflectors, right? Fine. But this time it will be having only one cluster ID inside the cluster list, and the originator ID will be router 1's router ID, right? So whenever this R3 will receive it, because this time it is not working as a route reflector, right? So because of it is not working as a route reflector, so it will not compare its cluster ID. It will simply compare originator ID. So it will compare its router ID with the originator ID. If it find its own router ID same as originator ID, it will simply discard them. It will not accept them, right? So this time it will not match, so it will accept them. But this time R3 is not going to advertise them towards R4. So again we have to configure it as a route reflector. Then you will configure this R4 as client, and of course you can configure R2 as a client itself, right? For R3. So this is different cluster now. This is different cluster now, right? So whenever now R3 will advertise this prefix towards R4, inside cluster ID 222 was already there. Now it will be having 333 as well inside cluster list because it has also crossed this R3, and R3 is working as a route reflector. But inside originator ID, you understand? Inside originator ID still it will be 111. Remember, once originator ID will get attached to your prefix, now it will always remain same. It will never be modified. Once originator ID will attach to your BGP update, it will never get modified again. And you know very well that it is locally significant. I mean local to AS, right? It is local to AS. It will never across AS boundary. Because whenever it will be giving an update to its eBGP neighbor, it will simply strip, it will simply remove these two attributes like cluster ID and of course originator ID. I hope you people have understood it now, right? Fine. That is why now if you are having this type of diagram, this is router 1, this is router 2, and this is router 3, and this is 12.1.1, and this is .2, this is 23.1.2, this is .3, and this is 13.1.1.3, and this is what 13.1.1.1. There was a prefix in .1.1.0/24. You are giving it to R2, but you are not giving it to R3, right? You filter out. You are filtering this prefix so that it is not advertised in the direction of R3. Now you configured R2 as a route reflector, R1 as client, R3 as client. So it will be giving this update to R3, and in that update you see that inside cluster ID, tell me, it will be 222. Inside originator ID it will be 111. But now R3 is not going to advertise that towards R1. But once again I configured R3 as a route reflector and this R2 as client, R1 as a client. Now R3 will be giving this update to R1, but at that moment inside cluster ID it will be having 222 along with 333, right? But originator ID will remain 1111. So whenever this R1 will receive this prefix back from R3, it will never accept that. So there will never be any routing loop even after implementing route reflectors in your BGP environment. Got it?
Yes.
So after implementing route reflectors, cluster ID and originator ID will take place to prevent your network from routing loops. Because you have broken IBGP, right? And if you have broken IBGP route, which means that there would be some possibilities of formation of routing loops, right? Fine. After it, let me tell you, let's say this is my core router. आपको पता नहीं है कि 9:30 की टाइमिंग्स हैं? आप डेली इसीलिए लेट आते हो क्या?
टाइम मुझे इन्फॉर्म नहीं किया, मैं बीच में घर गया होता हूँ।
अच्छा, तो वो तो देख लेते, डेली आप लेट आते तो पूछ लेते एक बार। क्लास
वही रिकॉर्डिंग 10-12 मिनट लेट चल रही होती तो मुझे लगा कि क्या पता थोड़ी आगे चल जाती है।
मतलब इस सॉफ्टवेयर में भी ऐसा कि 20 से स्टार्ट। फाइन, दिस इज राउटर 1, router 2, router 3. Core is having IBGP peering with all of them, and all of them are having lane networks, right? All of them are having IBGP peering. So by default, core is not gonna to exchange prefixes in between R1, R2, and R3. So you have to configure it as a route reflector. It will be client, client, client. Fine. And now you will see that R1 will be having lane network of R2 and R3 in their BGP table as well as routing table. Similarly, R2 will be having lane network of R1 and R3 in its routing table, BGP table. Similarly, R3 will also be having. Fine. But there is a single point of failure now. In case if your route reflector RR goes down, entire network will go down. So it is good to have a redundant route reflector. So do one thing, take another router and form IBGP peering with that as well. You see, in this manner. Even you can also form IBGP peering between core and R5 as well. I mean, this is core 1 and this is core, let's say 2. This is core 2, right? So you should have at least 2 route reflectors for the redundancy purpose. Otherwise, what will happen in case if R1 will go down, I mean, if one of the RR will go down, I mean, if your RR goes down, then entire network will go down. So it is always mandatory or not mandatory, it is always recommended to have redundant route reflectors in BGP environment. Hope you understood it now, right? And of course, there will not be any routing loop. And remember, right now you are having 2 route reflectors in a single cluster because both route reflectors are having neighborship with same routers. Is not it? Yes. See, we are not having multiple clusters. Right now we are having a single cluster over here, right? We are having only R1, R2 and R3. And all route reflectors are having neighborship with R1, R2 and R3 only. They do not have anything else. So remember, there is a rule or there is a recommendation that if you are having multiple route reflectors in a single cluster, then you should have same cluster IDs on both route reflectors. You should have same cluster IDs on both route reflectors. Once again, I'm going to repeat it. If you are having multiple route reflectors in a single cluster, then they should have same cluster IDs. You know why? If you do not have same cluster IDs on both of them, then you know, like core 2 is directly receiving prefix coming from R1, but same prefix core 2 will be receiving from core 1 as well, because core 1 is receiving from R1 and then core 1 can forward it towards core 2. However, it is not required anymore to receive, to exchange prefixes in between cores, except their own lane, right? So if you are having multiple route reflectors in a single cluster, then make sure that they are having same cluster ID. Right? But remember that if you are having 2 different clusters, they must not have same cluster IDs. Otherwise, they will never be able to exchange their prefixes with each other, right? What does it mean? I mean, like, how can we say that, okay, this is a same cluster, and how can we say that, okay, this is different cluster, right? So for that purpose, you just need to move back again. You see, this is router 1 and this is router 2, and this is router 3, and this is what, router 4, and this is what, router 5. So you are going to configure this router this R2 as router reflector, this is client, this is client, so it will be known as single cluster. Now R3 is not going to advertise that prefix towards any other peer, right? So you have to configure this R3 as a router reflector, this is client, this is client, so it will be another cluster, right? And now you will try to configure this R4 as a router reflector, right? Client, client, so it will be a different cluster. Of course they are overlapping to each other, but the point is that they are different clusters. Because right now you see R2 is not having direct neighborship with R4 or with R5, right? So usually you will not get IBC peering in this manner. In most of the cases you will find your IBC peering in this manner only. Like I said, there will be a core router and then it will be having IBC peering with all others, so that you can configure it as a router reflector and all others as a client. You understand? And for redundancy purpose you can have another core and then IBC peering between another core and the routers, right? And then you can also configure it as a route reflector, client, client, and client. You understand? So now you are having redundant route reflector. So if you are having redundant route reflector in a single cluster, then they should have same cluster IDs. But if you are having two different clusters, make sure that they are having different cluster IDs. Otherwise, they will not accept prefixes coming from there, right? Like once again, I will draw the older diagram R1, R2, R3. You understand? And then this is R4. You configured it as a route reflector, you configured it as a route reflector. So if both of them, see, if there is a prefix and .1.0/24, if both of them are using same cluster ID 222 and this is also 2222, whenever R2 will be giving this update to R3, now will R3 accept it? No, because it will compare, because it is working as a route reflector, so it will compare its cluster ID with its own cluster ID, right? If the cluster ID coming inside the cluster list of received updates is same as its own cluster ID, then it will simply discard all those prefixes, right? So it will not receive it. In DShoot they can do this, so that they will not be able to exchange their prefixes with each other. So at that moment you will require to change their cluster IDs. Any problem? Sure. So this is the uses of cluster ID, and this is called like single cluster, multiple clusters, right? You can also have your diagram in this manner as well. Like this is R1, this is R2, this is R3, and this is what? R4. You can configure now R1 as a route reflector, this is client, this is client, and then let's say R4 was also having some neighborship with the R5 and with R6, then you have to configure this R4 as a route reflector. This is client, right? And further might be possible that R6 is having neighborship with some other devices as well, then you will require to configure this R6 as a route reflector. But make sure that in this condition this route reflector must have, these route reflectors must have different cluster IDs, because they belong to different clusters, right? You can see that R5 and R6 are not having direct neighborship with R1. That is why R1 cannot become route reflector for R5 and R6. Remember, a router can be route reflector for directly neighbors, right?
So in this example, if suppose R3 is not a client,
it will work fine, no worries, because there is a rule. If you remember that in previous class, in that class I taught you that client and non-client, RR can reflect between them, between client and of course client. RR can reflect prefixes between them, but
so if R3 and R5 are not,
no, don't think like that, because for R3 route reflector is only R1, right? If this is non-client and this is non-client, then R1 will not be able to reflect routes between R2 and R3. If you are saying that okay, R3 is non-client, and you are talking about this route reflector, right? So this is the only router which is non-client, so it will work fine without any problem. Right, so this is the uses of originator ID and cluster ID in route reflectors. Fine, I'm gonna draw this diagram now. R5 customer edge, R6 is customer edge, right? So I'll draw this diagram in this manner. I don't have console of R3, so I will be using R4 only, right? And there I will configure IBG peering in this way. Now I'll be configuring. You know very well that these devices are connected with ISPs, right? And this is what customer's network. So I can configure this R5 as a route reflector, this R6 as a, and all of them as a.
You said reflected routes would carry cluster ID and originator ID.
Yes,
So,
only reflected. Yes,
so reflected means what
which
is
are received
receiving
from one of the IBGP neighbor,
any neighbor.
any
Whether
neighbor,
it's
any
a client,
IBGP neighbor.
whether it's a client
It's
or
a client or non-client, doesn't matter. Because if it is receiving it from non-client, it can still advertise them towards clients.
Right.
So before advertising them towards client, it has to add those two attributes. First, originator ID, and second, cluster ID.
So except self-originated, it will append cluster ID and originator
It will not
ID to
append
all.
cluster ID. No. In
Except-
self-advertised,
Except, I said except.
yes, of course. Not only self-advertised, even if it is having one EBGP neighbor and if it is receiving anything from the EBGP neighbor, then and if it is giving them to IBGP, then also it will not append cluster ID and
Okay.
originator ID. If it is receiving anything from
Or maybe
EBGP.
any external route. Like
Because if
OSPF.
you are receiving anything from EBGP neighbor, you can easily advertise them towards IBGP neighbor, right?
Right.
So over there, it is not reflecting. It is, see, route reflectors are made for IBGP BS only, which means if it is receiving from IBGP neighbor and giving them to IBGP neighbor, then only it will be adding these two attributes, right? So I'm gonna draw this diagram now. Fine, accordingly I have to design it now. From R1 I'm going to remove BGP, no router BGP 67500. Similarly I'll remove it from R2. Similarly I will remove it from R5. As well as I'll remove it from R6. Now you see R5 is having neighborship with R1, R2 and R4. And R5, from R5, the loopback of R1, R2 and R4, all of them are reachable, right? With the help of OSPF. Router BGP 65500, you see neighbor 150.1.1. Remote ASIS, and then update sources. I'm not doing anything else, right? The neighbor 150.1.2.1, remote ASIS 65500, and update sources. Then neighbor 150.1.4.1, remote AS is 65500, and update source is loopback 0. Fine. R6 is also there. Similarly, I'll do configuration on R6. Router BGP 65500, neighbor 150.1.1.1, remote AS is 65500. Then update source is update source for update source. Any problem? Right now R5 and R6 are not having neighborship with their ISPs. I have broken that neighborship, right? I'm just drawing this diagram. This one, R5 and R6, right? Then I'll move on R1. I'll create one loopback 1, and network is 10.1.0. I think it is not configured anywhere. Yes, it is not configured anywhere. So 10.1.1.0/24. Oh, sorry. Dot 1, right? Say router BGP 65500. Neighbor is 150.1.5.1. Remote AS is, tell me, 65500, and then update source is loopback 0. Then remote AS is for 6.1, and similarly I have to configure update source for 6.1. Any problem? Now it will form neighborship with R5 and R6 both. Similarly, I'll move on R2. Router BGP 65500, neighbor 150.1.5.1, remote AS is 65500, and along with that I'll configure update source is loopback 0. Then I'll be configuring remote AS for 6.1, and update source is also there. Router BGP 65500, say neighbor 150.1.5.1, remote AS is 65500. Update source is loopback 0, 6. We are done with the configuration, but we have to advertise, on R1 I'm going to advertise 10.1.0, and mask is this, sorry. Similarly, I'll move on R2, create one loopback 1, IP address 20.1.1, BGP 65500, network 20.1.0, mask is this. On R4, loopback 1, 40.1.0. You understand? And then router BGP 65500, network 40.1.0. Done. Now R1, R2 and R4, all of them will be giving an update to R5 as well as R6, but R5 and R6 will never reflect routes between them, right? That is why you can move on R5 now, and R5 and R6, they do not have neighborship with each other right now, right? I haven't configured IVC pairing between R5 and R6. So now you do one thing, move on R5 and say show IP BGP. Check it out. It is receiving 1020. So 10 prefix is coming from 1, 20 is coming from 2, 30, 40 is coming from 4. You understand? And similarly, R6 will be receiving that. So IP BGP, check it out. 10, 20, 40. Right? So that's the thing. But now look at the BGP table of R1. it won't be having anything except it's on, because R5 and R6 are not giving all these updates to R5 that were received from R5, sorry, R2 and R4. So this time you have to do one thing, you have to configure this R5 as a route reflector. You understand? So once you will move on R5, commands will be something like this: 150.1.1.1. Say route reflector. Similarly, route reflector. Similarly, I configured now this router as a route reflector, right? And now you see show IP BGP. There is no difference at all, right? But if you look at R1 now, on R1 you will get that the loop back, the lane network of R2 and of course the lane of R4 is not it, and next hop has not been changed, and it is beneficiary for us. If you want to go from R1 to R2, from R1 to R2, if next hop was modified from R5, then it should have came through R5, right? It should have traversed to R5 to reach R2 from R1 to R2, right? But this time, because next hop was not modified, so whenever R1 will require to reach R2, it will directly forward traffic into the direction of R2. So it will reach R2 without traversing R5. So this is an advantage of not modifying next hop address in case of IBGP, right? So next hop is still 222 and 44. However, if you open them, show IP BGP 20.1.0, you can look at here that in actual it is given by 5. Next hop is this, and there are two new things now: originator and destination. So originator ID is the router ID of that router from where route reflector received prefix. So route reflector, who is route reflector? R5. R5 was receiving this prefix from R2. That is why R2's router ID has been defined as a originator ID, and cluster list it's a router ID of route reflector itself. Tell me. Similarly, you will move on R6 and you can configure this R6 as a route reflector, as a redundant route reflector, right? Router BCP 65500, neighbor 150.1.1.1, route reflector client 150.1.2.1, route reflector client, neighbor 4.1, route reflector. Fine. So IP BGP, nothing, no change, it's same as previously, but changes will appear on R1. Now this 1020's prefix will be coming. It is looking like same neighbor is giving us this prefix twice, right? But in actual, this is next hop address, right? This is not your neighbor's address. This is next hop address, and next hop address remains same. Right? If you open show IP BGP 20.1.0, you will see now from R6 as well as from R5, and this is best actually, because path selection has to be followed now, and rules will remain same. So now it is receiving this 20's prefix from both route reflectors, and that is why with both it is having originator ID and cluster list. That is why there is no possibility of formation of routing loops, even after breaking up IBGP route with the help of route reflectors.
So it's a single cluster.
Yes, it is a single cluster. In a single cluster, we are having multiple, redundant route reflector right now. Because R5 and R6, they are having IBC pairing with same devices.
So you said that we should have same cluster ID.
Yes, on R5 and R6.
But in this case, it is
Yes, because of R5 and R6, they do not have IBC peering between them.
okay.
And even if you do not configure same router IDs, same cluster IDs on both router reflectors in a single cluster, then also it is fine. It will work fine. But actually, it is recommended to have same cluster IDs on both router reflectors if you are having redundant route reflector in a single cluster.
So if it was having same cluster ID, the router one would be receiving one route only, test route, or
No,
it
no,
would
no,
still
no.
get two routes.
No. It will still get two routes. You know why? Because R2 will be giving to both of them, R5 as well as R6. So R5 and R6, both of them will be giving it back to R1. If you do not configure same cluster IDs on both router reflectors, now R1 will be receiving from like R5. This time R5 is receiving these prefixes coming from R1, R2 and R4, and then after it will also start receiving them from R6 as well, if they do not have same cluster IDs.
If they do not have,
Yes.
But if they have, then
Of course R5 will be receiving them from R1, R2 and R4 only. It will never receive it from R6.
R1 will get only one route.
Yes, R1, yes, from R5 only, or from R5 as well as from R6.
Either one of that.
Not from one of them. R1 will still be having prefixes from both of them. See, this time R5 is route reflector, right? R6 is also route reflector. R5 is having IBCP pairing with R1, R2 and R4 from all, with all. So R5 is receiving all the prefixes coming from R1, R2 and R4, right? But R5 is not giving it to R6. R6 is receiving prefixes coming from R1, R2 and R4. R6 is not getting them from R5, right? But if you configure IBC pairing between R5 and R6, then for R5, R6 will be non-client, and for R6, R5 will be non-client. If it is receiving anything from one of the client, it can easily advertise them towards non-client. So if R5 is receiving anything from R1, R2 and R4, it will be advertising them towards R6. However, R6 does not need those updates to receive from R5, because R6 is already having all those prefixes in its BGP table coming from R1, R2 and R4. So why? What is the need to receive all same prefixes from R5 if R6 is already having direct neighborship with R1, R2 and R4? So if you configure same cluster IDs on R5 and R6, so if R5 will be giving any reflected route to R6, it will simply drop them. Simple. That is the only difference. However, if we do not configure same cluster IDs on both route reflectors, then also it will work fine, because originator ID can still prevent your network from routing loops. I'm going to form IBC pairing between R5 and R6 as well now. So let's move on R5. Router BGP 65500, neighbor 150.1.6.1, remote ASs 65500, and same update sources loopback 0, right? Similarly on R6, router BGP 65500, neighbor 150.1.5.1, remote ASs 65500, and update source is going to be now check it out. On R6, 10's prefix, 20's, 40's from two different neighbors. However, it should have received 10's prefix from R1 only, but this time it is receiving them from show IP BGP 10.1.0. Check it out. One is coming directly from R1 itself. You see, it is coming from R1 itself, and if it is receiving it from R1 directly, then it does not have anything like originator ID and cluster at least, right? But if it is receiving from R5, then it is having, right? So it is not necessary for them to receive, it is not necessary for R6 to receive them from R5, and similarly you will get them on R5 coming from R6. It is not necessary, right? So to solve this problem, what can I do? I will move on R5 65500, I will say BGP cluster ID is like 5.5.5, and similarly I'll move on R6. I'll say router BGP 65500, BGP cluster ID is what? 5.5.5. Same cluster IDs are configured now on both route reflector. So this time you will see show BGP. Check it out. Does it have anything coming from R5 now? Now let's move back again on R5. Will it have anything in its BGP table coming from R6? No. I mean refracted by R6. Of course no. Because right now they are having same cluster IDs.
But R1 would still have two routes.
You can move there. You can check it out. Show IP BGP from R5 as well as from R6. Right? So R1, R2 and R4 will still receive prefixes from both route reflectors.
So either we don't form neighborship or we keep same cluster IDs one and the same.
You know, like sometimes what happens, let's say R5 and R6, they are also having their directly connected prefixes. What to do now? If R5 and R6 are having their directly connected prefixes, if let's say that you are not having neighborship between R5 and R6, right? And if R5 is advertising anything and R6 is also advertising anything, will it be possible for R5 to receive the lane network of R6, and will it be possible for R6 to receive anything coming from R5? Of course no, because they do not have direct neighborship between each other. So if R5 and R6 both of them are having their lane networks, then it is mandatory to form IBGP peering between R5 and R6 so that they can exchange their lane networks with each other. Because R1, R2 and R4, you are not using them as a route reflector. So it will always require to form neighborship between route reflectors as well. Might be that they are having some lane networks, right? So just to exchange their lane networks, it will be required to form IBGP peering between route reflectors as well. I hope you people have understood all these concepts of route reflectors, right? So as I told you that if any route reflector receives anything from any client or non-client, if it receives any update, first of all it will compare its cluster ID. If its on cluster ID is same as that cluster ID which is coming inside the updates, then it will simply discard all those updates, right? So these things will be used for loop prevention only. Any problem in it? Sure. Then route reflector is done. I have taught you all the concepts of route reflectors now. Fine. Now, one another objective is also present of route reflectors. That is called confederation. Confederation. It is an objective of route reflectors, because you know, if you are implementing route reflectors in enterprise network, then of course there will be too much route reflectors. There will be requirement of having too many route reflectors. And if you are having too many route reflectors, means that your cluster list will become huge. And in somehow, you know, there can be some possibilities of routing loops as well. If you are not using, you know, same cluster IDs in on route reflectors, on multiple route reflectors in the same cluster, then you know it can cause. Sometimes it can cause a problem, right? So it is not reliable to use route reflector in enterprise networks. It is always good to use confederation. And confederation is something like private VLAN. Do you remember private VLANs from switching? Like we were using a main VLAN and the secondary VLANs, primary VLAN and secondary VLAN. Similarly, here in confederation, you will be using primary AS and secondary AS. Like for an example, what can you do? Let's say this is R1, this is R2, this is R3, R4, R5 and R6. And then further they are connected with ISP, really BGP, right? And all of them are having IBGP, same AS, right? AS 100. Now you will require to configure multiple route reflectors over here, right? To get exchange routes between them. But what can you do? You do one thing, configure AS 30, AS 40, AS 20, secondary AS, right? AS 60, AS 10, sub AS, right? 50. Now they will become EBGP peer. So this confederation, confed EBGP peer will be having some features of real IBGP and some features from real EBGP. Like here, now if you receive anything from confed EBGP, then you can advertise that towards towards another confed EBGP. That is, this behavior or this feature was taken from real EBGP, right? But next hop will not get changed, and also it will carry forward local preference when it is giving an update to confed EBGP neighbor. In real EBGP neighbor, it does not include local preference, but in BGP, if it is giving an update to its confed EBGP neighbor, then it will always include local preference. So some features are taken from IBGP and some features are taken from real EBGP, right? Like next hop will never get modified automatically if it is giving an update to its confed EBGP, right? It will remain same as IBGP. This feature was taken from real IBGP, but you will not require to configure route reflector. So you will be required to configure some sub ASs in your there will be two things, primary AS and secondary AS. Remember that whenever you will be giving an update to your real EBGP neighbor, then it will remove sub AS's information from outgoing updates. It will never give, it will never include sub AS's information, you can say secondary AS's information in outgoing updates towards real EBGP neighbor, right? So whenever it will be giving, BGP will be giving an update to real EBGP, then it will always strip secondary AS information from its outgoing updates. Understood? So this is the way in which it works. Sometimes we uses combination of route reflectors and this confederation. In some of the cases you will be using combination of both of them, and that is good actually. In most of the cases, in most environment, you will find the combination of route reflector and confederation, like in this manner. Let's assume that this is ISP1 and this is your ISP2 and this is customer edge 1 and this is customer edge 2. Then it is having R1 here, then R2 is there, then R3 is there, then they are having IBGP peering, right? R4 is there, then R4 is connected with customer edge 2, then R5, and then R6 is also there, right? So what can you do now? You can put them in same sub AS, right? Secondary AS. Like here, all of them are running a primary AS, that is AS65500, right? This is the primary AS of this customer. But what can you do in this portion and in this portion? You can use sub AS, right? Here use sub AS, let's say 10, and here you are using sub AS 20. So here it will be having EBGP, right? And here they will be having IBGP. So you will require to configure this R3 as a route reflector. Then similarly, R4 will be required to configure as a route reflector, so that it can reflect routes between confed IBGP peers. So you can use the combination of both confederation and, you understand? But here you could ask him that, okay, what is the advantage of running confederation if we are configuring them as route reflector? It will work fine even without configuring. Let's assume that there is one another router also exists over there, let's say R10, and of course it will be really helpful. You will not require to configure too many route reflectors in your AS, right? So because it will become EBGP, and if it is receiving anything from confed EBGP, then it can advertise them towards another confed EBGP. Understood? So this is the way actually to do it. I'm going to perform it now. Here I'm having like R1 is there, then R5 is there, R2 is there, R4 is there, R6 is there, and then it is connected with a sprint and then BTS1 in this way, right? And they are interconnected. They are using common AS, that is what, 65500. I'll be using AS50 here, 60, sub AS is 40, 10 and 20. And we will see that we will not require to configure any route reflector, and it will work fine. So if someone asks you that is it possible to run multiple ASCs on a single device in BGP? Yes, it is. Like I'm gonna to do it now. Primary and secondary. Right? Fine. So I'm gonna to remove the configuration from all devices once again. You see, no router BGP 65500. I have removed it from R1. Similarly, I'll remove it from R2. Similarly, I will remove it from R4. Similarly, I will remove it from R5. And of course from R6. Hope you have understood it now. Now let's start it. On R5, see, fine. On BT and Sprint, I'm not gonna to change their remote ASs, right? And in remote AS on BT, I configured 65500 on Sprint as well, right? I'm not gonna to modify the configuration of Sprint and BT, and we will see that they will form neighborship. Let me show you on R5. Router BGP, as I told you, I will be configuring S50. This is sub AS, right? Now I have to tell this router that what is your primary AS. To tell that, command is going to be BGP configuration identifier. BGP configuration identifier, and in it, understand, you have to define your primary AS. That is what 65500. That's fine. That's the only thing that you need to tell here, right? And now you do one thing, configure neighbor 201, 200, 105, 100.1. Remote AS was 35500. Similarly, neighbor 205, 100, 100.10. Remote AS is 21545. And you will see that neighborship will come up now automatically. You see, neighborship has came up. Although I didn't change the configuration of BT and Sprint US. You can check it here. Show IPPG. Check it out. Yes, it has received. Oh, fine. Let's do one thing on Neo router. Actually, I'm using some other prefixes. I have to configure 100.1. Remember, and then 101. Then of course 102. 103. And router BGP is using 8127 network. Fine. Now on R5 you must get only these prefixes, right? Oh, it haven't removed. BGP converts slowly. It converts slowly. So fine. It is receiving these prefixes now. Done. Similarly, we can move on R6 and we can configure this R6 as well. Say router BGP what 60 BGP configuration identifier is what 65500. Neighbor 201, 100, 100.1. Remote AS is what 35500. So now neighborship must come up between R6 and BT. Done. So I will BGP. Now according to the diagram, R5 must have neighborship with R1 as well, and R1 is using AS 10. So what will I say on R5? I'm on R5 first of all, right? Router BGP 65500. Sorry, it is using now 50, right? So you have to say BGP configuration. Previously I configured identifier, which means that you have to define your primary AS, right? But now you have to tell that in which sub AS your peer is existing, right? So right now R1 is existing in AS, peers are in. If you are having peers in multiple sub ASs, then you will be saying 10, 20, 30, something like that. But this time only 10 is there, right? And then say neighbor 150.1.1. Remote AS is neighbor 150.1.1. Update sources loopback 0. Neighbor 150.1.1 EBGP multi-hop. This is now, this feature is taken from real EBGP, right? So we have to say, let's say I have said 3. Any problem? Similarly, I'll move on R1 now. R1 is using AS according to diagram 10. So I'll be saying router BGP 10. BGP configuration identifier is what? 65500. Now BGP configuration peers, you have to tell that in which ASs your peers are existing. So AS 50 and 20. R2 is also there, right? So I'll be saying peers 20 and of course 50. And then you have to say neighbor 150.1.5.1. remote AS is going to be 50, and neighbor 150.1.5.1 update sources loopback 0. Neighbor 150.1.5.1 EBGP multi-hop is what? 3. And now you will see that in between R1 and R5 neighborship will come. Similarly, neighbor 150.1.2.1 remote AS is what? 20. Neighbor 150.1.2.1 update sources loopback 0. Even I can advertise its own lane. Mask, right? Then I can move on R2. Okay, I didn't configure that. Okay, neighbor 150.1.2.1 EBGP multi-hop 2. Leave it. Let's move on now. R2. R2 is having neighborship with again R1 and R4, both of them. So what can I say on R2? That router BGP 20 BGP configuration identifier is what? 65500. BGP configuration identifier.
So this identifier is mandatory to be specified on each router. Not
And
just
otherwise,
BGP.
otherwise, how will it be possible to know that okay, this is the primary AS, right? Because it is also possible that R2 is also having neighborship with real EBGP.
Really.
So BGP configuration peers 10 and of course 40, right? To say neighbor 150.1.1.1 remote AS is what? 10. Neighbor update source loopback 0. Neighbor EBGP multi-hop 2. Neighbor 150.1.4.1 remote AS is going to be 40. Neighbor 150.1.4.1 update source is loopback 0. Neighbor 150.1.4.1 EBGP multi-hop 3. Network 20.1.0 mask is going to be, move on R4. Router BGP 40. BGP configuration identifier is what? 65500. BGP configuration peers are in AS 20 and of course 60. So neighbor 150.1.2.1 remote AS is what? 20. Neighbor 150.1.2.1 update source is loopback 0. Neighbor 150.1.2.1 EBGP multi-hop 2. Neighbor 150.1.6.1 remote AS is 60. Neighbor 150.1.6.1 update source is loopback 0. Neighbor 150.1.6.1 ABGP multi-hop 3, whatever it is, right? Move on R6. Router BGP 60 BGP configuration peers. It is having only one neighbor which is in AS 40 only. So I'll be saying neighbor 150.1.4.1 remote AS is what? 40. And of course update source is going to be loopback 0, and of course EBGP multi-hop should be configured. Let's say it's 3 or 2 or whatever it is, right? Neighborship is there now between all. Now look at R1, show BGP, check it out. Next hop was not modified, right? However, it is giving it to confed EBGP, right? Confed alpha is giving it to confed EBGP, but still it is not modifying next hop. That feature was taken from IBGP. So on R5 you have to say that neighbor 150.1.1 next hop self. Once you will configure this command, now move back again on R1. It must be best path. And in brackets it is what? Sub AS. It is getting it from AS 50, and 20 is coming from AS 20 itself. Now you can move on R2. You can check show BGP. Check it out. It is also receiving them from via R5, right? And AS10 and 50, because it has across now AS10 as well. Sub AS10, right? R5 giving it to R1. R1 is giving it to R2. Then R2 will give it to R4. And look at here, show BGP. It is receiving it from 5 as well as from its R6, right? You can see from R6, but next hop was not modified. So you do one thing, move back again on R6 and say router BGP is what? 60, neighbor is 150.1.4.1 next hop self. Once you will configure this command, now on R4 you will see that both of them will become, now next hop is reachable via both, but still next hop, best is what? Via R5. You know why? If you open it 100.0. However, via R5 it has to across multiple sub ASs, but remember these sub ASs, secondary ASs, will never take place in best path selection. So based on ICP cost to reach next hop, best path is via R5, even from R4 as well, because in actual this topology is something like this. So this is all about confederation, and again you can use MED and everything, Confed AS path list will be new attribute added into BGP updates now after configuring configuration. Confed AS path list. This is called Confed AS path list. This one in brackets. Confed AS path list. But it will never take place in best path selection. Right? So this is the way. So here you don't require to configure any router factor or something like that. Nothing. No need to go for originator ID, cluster ID. Nothing. Tell me. Any problem in it? Sure. This is all about configuration. You could perform this practical in this manner as well, like R1 and R5 in same sub AS, right? And then these all in same sub AS. So you will require to configure now this R4 as a route, otherwise it won't work, because now it will be confed IBGP here, R2 as well as R6. So this is the way.
Thank you. Sorry to be so.
Any problem in it? When it is giving an update to its real BGP neighbor, then it is not advertising its sub AS information into that, right? You can look at BT, and on BT you must have tens prefix that was advertised by R1. Yes, only 65500. Nothing like 10, 20, 30 or something like that. Nothing. So this is the way, and MED is also coming with updates, right? Same as IBGP, like MED is always included in all outgoing updates while it is giving an update to its IBGP neighbor. So that's done.